Okay, welcome again. Let's still use the same structure of the kidney, of the nephron, sorry, to describe about the urine formation in just some 2 minutes. So, the dissolved material from the earth that it contains the urea. After the deamination process in the liver, what is being excreted will be the urea. It will enter the kidney through what? The afferent arteriole. We have the afferent and we have the efferent. Afferent is more wider, so this one is more wider than this one, so this one is narrow, and because of this wideness and the narrowness, it will be carrying a lot of dissolved blood, and because of this one there will be creation of some resistance at the afferent and the efferent. And what will happen? Ultrafiltration at this point. So the process that will take place at this point is ultrafiltration. We are saying ultrafiltration. So that is our process that will take place at the glomerulus, ultrafiltration. From that point, what are materials that will be filtered out? The materials that will be filtered out are those small sized molecules, which are those ones: glucose, vitamins. We have glucose, vitamins, mineral salts, that urea, even water. Those are the materials that will be filtered to the Bowman's capsule, and in the capsular space, that is what it will form. It will form something called what? Glomerular filtrate. It will form glomerular what? Filtrate. That is what is formed after ultrafiltration. From that point, we have some two materials that cannot be filtered. Which are those ones? The first one that cannot be filtered is the blood cells and the plasma proteins, and because of their life size, so they'll just leave through the efferent arteriole. From this point, the glomerular filtrate will flow to the Bowman's capsule, not Bowman's capsule, but to the proximal convoluted tubule. What happens in the proximal convoluted tubule? So let me just use abbreviation: proximal convoluted what? Tubule, or the proximal convoluted tubule. So we can say proximal convoluted tubule. What happens at that point? Selective reabsorption. We are saying at the glomerular, we said we have ultrafiltration. So from the proximal convoluted, it has some features: highly coiled, and this to reduce the speed flow of the glomerular filtrate and give more time for selective reabsorption. Number two, it has the thin epithelium wall to reduce the distance for the diffusion of those glomerular filtrate. It has numerous mitochondria to yield more energy for the active uptake of those mineral salts. Then we have again, they have numerous blood capillaries. So within all this lining, we will be having some blood capillaries. And what's the role for the blood capillaries? It will be transporting those reabsorbed materials. Then again, from that point now, we are saying what are selectively reabsorbed? The things which are selectively reabsorbed at that point naturally will be glucose. So you should understand glucose will not pass this point. And if it will be passed from that point, and maybe in the urine we find some glucose traces, it will be a good indicator that the person's kidney will be affected. And that is a good indicator that maybe this person has a condition called diabetes mellitus. From this point now, the remaining glomerular filtrate will flow down to the descending lobe of anal, then to the ascending lobe of anal. So what happens at the descending lobe of anal? It's permeable to water. So we are speaking about this point. It's permeable to water, impermeable to ions. So we are saying descending lobe of anal, and we are saying it's what? Permeable to impermeable to what? It's impermeable to ions. Then when you go to the ascending, it's opposite. It will be impermeable to ions, permeable to, it will be permeable to the ions, impermeable to water. It's the opposite of this one. That is the ascending lobe of anal. So what happens at this point? At this point now, a lot of water will be reabsorbed to the bloodstream. Then at the ascending lobe of ventricle, what will happen? And because of this one, it will decrease, the osmotic pressure of the blood. And when it decreases the osmotic pressure of the blood, what will happen? The adrenal gland will be stimulated to secrete aldosterone hormone. So we have an hormone which will be secreted at this point, and we are saying which is the hormone. We have aldosterone hormone. And what will happen to this aldosterone hormone? Once secreted, it will increase permeability. It increases. It's the adrenal gland which secretes the aldosterone hormone, increases permeability. We had said it's impermeable to what? We say this point was impermeable to water. So it increases the permeability of this point. And at this point now, when the permeability is increased, there will be active pumping of the sodium ions. So we increase the active pumping of the sodium ions at this point, and it will be followed by chloride ions. So we are saying sodium ions followed by what? Chloride ion for neutralization. So it will be sodium chloride. So the sodium chloride will be back to the blood, and this one will be aided by some energy, and we are saying that's why active pumping. When this sodium chloride will be more in the blood now, it increases osmotic pressure, and the osmotic pressure will rise back to normal. The remaining glomerular filtrate will flow to the distal convoluted tubule. What happens in the distal convoluted tubule? So at the distal convoluted tubule, you can say the sodium chloride was being injected to the blood. So from that point, the osmotic pressure can rise up to above normal. And again, when it will be high above normal, it will be detected by the hypothalamus, and it will send impulse to the pituitary gland. The pituitary gland will secrete another hormone called antidiuretic hormone, or you can call it vasopressin, the vasopressin. So, and what will be the role of this hormone? Increases permeability. It will increase what? Permeability of distal convoluted tubule. So at this point, it will increase the permeability of this point, and more water will be reabsorbed back to the bloodstream through the process of osmosis. The remaining glomerular filtrate will flow down to the collecting duct, and at the collecting tubule and the collecting duct, there will be more reabsorption of water by the process of osmosis. Then the remaining glomerular filtrate will flow to the urinary bladder. So we are saying at this point, we will have our urinary what? Bladder. So it will go to the flow to that urinary bladder, and it will be stored temporarily. And once it will be stored temporarily, once this bladder is full, it will be emptied through the urethra. That is how. When you're told describe urine formation, describe the structure of the kidney to its function. Thank you very much.